early Earth spins 3 times faster than today. The winds howl due to the aerodynamics of Earth's quicker rotation.
Jupiter, for example, is a giant planet that spins very rapidly. It has a 10-hour spin period. And it's got ferocious winds in its upper atmosphere, hundreds of miles an hour, and incredible storms like the Great Red Spot, which has been around for centuries. Now, Earth probably would be spinning more rapidly than it is now. And that would generally lead to stronger winds and more violent hurricanes and other storms.
Early Earth's fast spin results in another important side effect.
The rotation of Earth's core, particularly the molten part of the core, is believed to be what generates our magnetic field. And so the Earth rotates 3 times faster, the magnetic field is 3 times stronger.
The enhanced magnetic field over the moonless Earth more effectively deflects high-energy solar flare particles towards the Earth's poles, resulting in larger, more spectacular auroras. But by blocking the solar flares, not as much radiation zaps life in the lower atmosphere, decreasing mutations that drive evolution.
Stronger magnetic field might have slowed the rate at which life evolved on Earth.
Stronger magnetic field might have slowed the rate at which life evolved on Earth.
Without the moon, the developing Earth suffers intense climate volatility. Over many periods, each lasting several million years, the Earth's axis is pulled and pushed by the Sun and other planets without the stabilizing influence of the moon. Conditions would have paralleled what happened to Mars.
What we've learned in the last 15 or 20 years is that Mars has a very unstable axis because it has no big moon. And when we look at Mars, and we can actually see on the surface of Mars geological features that formed under very different climate regimes when the polar axis was tilted over. On Mars, we actually see these features like the dry river channels and glacial deposits and other features, ice close to the equator. And so the big realization was, oh yeah, the climate has been changing on Mars, and this explains that we're seeing older features.
Like the red planet, a moonless Earth's axis would tilt wildly, turning our planet topsy-turvy.
Our axis, over a period of millions of years, would wobble chaotically. It would sometimes be vertical, it would sometimes be close to horizontal. When it's vertical, then the whole Earth might be kind of a tropical paradise. When it's horizontal, you could actually have the poles pointing towards the sun and the poles actually getting jungles. So you'd see very big changes in Earth's climate as a result of this chaotic wandering of Earth's axis. And this would make it more difficult for life to flourish because it would constantly have to adapt to different conditions, to ice ages and to extremely hot ages.
So what would life on Earth look like today if we had never had a moon? Short days, high winds, and other changes could produce a freakish world with creatures that look like they're straight out of science fiction. The moon was formed billions of years ago when a planet-sized asteroid crashed into Earth. But what if that violent collision never happened? If the moon never came along to stabilize our planet, Earth would be an alien place. The spin of early Earth was very fast, with about 4 hours of daylight followed by 4 hours of darkness. Over billions of years, the sun's gravity and tidal friction would lengthen that 8-hour day to 12 hours. But this is still twice as fast as the current Earth spins, which makes for some extreme weather, including devastating storms and high winds.
If the moon hadn't formed, you certainly get a wildly different environment on the Earth. With a faster turning Earth, you get more jet streams, you get more turbulence probably, maybe bigger storms, more lightning because of the friction of the different masses of air moving.
In some places, the winds could reach 100 or 200 miles an hour. There would also be stronger hurricanes, and the Earth would have larger waves battering the coastlines.
And without the moon's stabilizing effect, the rapidly spinning Earth tilts back and forth. Over hundreds of thousands of years, our planet suffers the ravages of ever-shifting climate because of the erratic changes in axial tilt. As different regions are blasted by heat, then covered by ice again and again. And without the moon, there is another layer of axial instability. Even though today's Earth is stabilized by the moon, there is still a wobble to the Earth's rotation, known as precession.
Earth's tilt is 23.5 degrees, but over a period of 26,000 years, it goes through conical variations like this.
And if the moon had never formed, this wobbling would be much more unpredictable.
If we didn't have the moon, the Earth would precess much more slowly, and this is one cause for chaotic variations in the axial tilt. A slower precession of the Earth would lead to a much more unstable axis of rotation for the Earth.
Without the moon, Earth's axis today would be like the slower spinning top, precessing, gyrating, and wobbling in ever larger conical circles.
Right now, 26,000 years.
Right now, 26,000 years.
Very stable zone. You get it going slower, so it's maybe 40,000, maybe 50,000, maybe 60,000. Then you hit the chaotic range, and then everything goes wrong.
With the more forbidding and shifting climate, evolution on a moonless Earth varies between bursts of adaptation and violent extinction. Bizarre life forms mushroom. Plant species are vulnerable as they don't have the mobility to stay ahead of speedy climate change. And complex life forms like humans probably wouldn't stand a chance at all.
And complex life forms like humans probably wouldn't stand a chance at all.
The variations in climate would be extreme and rather rapid, and it would probably make it difficult for complex creatures to evolve, because most complex creatures can't evolve very quickly to changes in their environment.
Instead, primitive organisms would predominate and endure.
Bacterial life is able not only to adapt more quickly, but also to withstand more extreme environments. We see bacteria under the deep ice cores of the Antarctic or Greenland, and we see bacteria that live in steaming, boiling pots in Yellowstone.
If complex life were to evolve, it would look very different due to short days, high winds, and other features of a moonless Earth.
You should see the things we